Although arc hazards have existed since we first started using electricity, increasing deaths, injuries, and property loss from arcing faults have led to increased study into the causes, effects, and methods of protection. New electrical standards, most notably the Fire Protection Association or NFPA 70E, are the principal regulations to establish minimum requirements for improving electrical safety. OSHA has adopted these regulations, and they apply to every worker that may approach or be exposed to electrical energy. Let's review arc flashes. When electric current flows between two or more separated energized conducting surfaces, an arc occurs. Some arcs are intentional, such as arc welding, or they may be accidental, caused by a tool touching a probe to the wrong surface. One common cause of arcs is insulation failure. Temperatures at the arc terminals can reach or exceed 35,000 degrees Fahrenheit, or 4 times the temperature of the sun's surface. The heat energy and intense light at the point of the arc is termed arc flash. Air surrounding the arc is instantly heated and conductors are vaporized, causing a pressure wave termed arc blast. It's more like an explosion. Anything that produces electrical current has the potential to produce an arc, even a 12-volt battery. However, in the electrical industry, arc flash is described as the sudden release of large amounts of heat and light energy at the point of the fault. Exposure to an arc flash frequently results in a variety of serious injuries and, in some cases, death. People have been seriously injured even when 10 feet or more from the arc center. If there are nearby flammable materials, these can be ignited, resulting in secondary fires that can destroy entire facilities. Not only are arcs themselves dangerous, but loud sounds and blast pressures can cause injury or death. The arc blast often causes equipment to literally explode, thereby ejecting metal parts, insulating material, and supporting structures with life-threatening force. In many cases, it's like a shotgun exploding in your face, and often it's so fast you never even know it. Arc flash can happen instantly, and the pressure blast can cause shrapnel to be hurled at high velocity exceeding 700 miles an hour. So let's just say that arc flashes and blasts can be life-threatening and require special attention and training to prevent such occurrences. If you're not an electrician, you may be thinking that this training program is a waste of time because you don't work on electrical equipment. You may not work on or install electrical components, but the information is extremely valuable, regardless of what job you may have or how little you may be exposed to electrical hazards. Certainly electricians and maintenance persons working on or around electricity are at an increased risk, but everyone should be trained in basic arc flash safety procedures. The safety activity in the electrical industry these days is focused on shock and arc flash hazards. Everyone knows about electrical shock, but we're still experiencing deaths and serious injuries each year from shock hazards. One of the best ways to prevent shock is to utilize finger-safe products and non-conductive covers or barriers. If all the electrical components are finger-safe or covered, a worker has a much lower chance of coming in contact with a live conductor. There are new fuses that are classified as finger-safe as well. The new requirement for NFPA 70E to reduce the risk of injury due to shock and arc flash hazards is for a flash hazard analysis. In other words, before workers approach exposed electrical conductors or circuit parts that have not been placed in a safe work condition, the flash hazard analysis must be performed. The analysis should determine the flash protection boundary and level of personal protective equipment the worker must wear. A flash protection boundary is the distance from the energized parts at which a worker could sustain a curable burn as a result of an arcing fault. Some basic rules apply, but it's necessary for your organization to develop specific boundaries for all electrical equipment you use. Generally, up to 750 volts, the boundary is 3 feet. 750 volts to 2,000 volts, the boundary is 4 feet. 2,000 to 15,000 volts requires a 16-foot boundary. 15,000 to 36,000 volts of electricity require a 19-foot boundary. Any voltage over 36,000 must be independently calculated. A worker entering the flash protection boundary must be qualified and must be wearing appropriate personal protective equipment. When we say appropriate PPE, that means special arc flash PPE and clothing. In an actual situation, before a worker is permitted to approach equipment with exposed live parts, these arc flash boundaries must be determined and proper level of PPE established for the particular boundary. These boundaries must be calculated by determining the incident energy. We're not going to discuss how the boundary is determined, as it is a highly technical process and will be performed generally by electrical engineers. There is also numerous software available for developing these arc flash assessments. We want to make the distinction of personal protective equipment as it applies to arc flash and boundary assessments. It's much more than wearing gloves and safety glasses. Examples of the equipment could include a hard hat, face shield, flame-resistant neck protection, ear protection, Nomex suit, insulated rubber gloves with leather protectors, and insulated leather footwear. NFPA 70E has specific requirements for PPE depending upon the potential hazard. Protective equipment sufficient for protection from an electrical flash would be required for any part of the body which could be within 3 feet of the fault. That is why the assessment is so important in establishing boundaries to select the appropriate PPE that will protect you in the event of a flash. The common distance used for most low-voltage incident energy research and testing is at 18 inches from the arcing fault source. If a person is closer than 18 inches, the higher the incident energy and blast hazard. In other words, if the body has sufficient PPE for an 18-inch working distance, severe injury can result to any part of the body closer than 18 inches to the source of the arc. Just remember that if the label of PPE does not have an arc rating, ATPV, it is not arc flash protection. Arc flash PPE is much more than fire retardant. Arc flash protective garments are designed and tested to insulate the user from harmful energy, not just self-extinguish. What differentiates an arc flash garment from a fire retardant garment? The arc protective rating, or ATPV. NFPA 70E and ASTM F1506 require that an arc flash garment be marked on its label its specific arc protective rating. This will state in black and white the level of the protective characteristic of the product against an arc's energy. This arc rating is determined by a specific test procedure, ASTM F1959, where an arc flash is created in laboratories to simulate real-world conditions. Under these conditions, the protective characteristics of the material from which the garment is made is determined. Without this arc rating, the garment is simply a work shirt and should not be used as arc flash protection. Some electricians and maintenance persons will say they always work in a de-energized condition, so protection is not really needed. How does an employee know it is de-energized? To determine if it is in fact de-energized, the employee needs to test for the absence of voltage using a voltage tester. To conduct this test, he or she must enter into the prohibited or restricted area. To cross the prohibited approach boundary, the person conducting the work must have specific training, have a documented plan justifying need for work within the restricted area, perform a hazard assessment, have a work plan and analysis approved by an authorized person, wear PPE rated for the hazard. So to make a long story short, you need specific and authorized personal protective equipment when working on or near electrical equipment. While an arc flash explosion does not occur every day within a facility, and with luck may never occur within one's professional life, arc flash incidents do occur daily somewhere in North America. We all have responsibilities. This is dangerous work we perform on a daily basis. Each death and severe burn injury which occurs as a result of an arc flash explosion is pointless and preventable. If work is conducted by a knowledgeable, trained electrical worker, and he or she is wearing arc-rated arc flash clothing suitable for the hazard of the task, every electrical worker can expect to return safely from work. In addition to the PPE requirements, the latest update to NFPA 70E provides a requirement for field labeling and a requirement that work on energized electrical equipment have work permits to ensure people performing this work are properly trained and equipped. Arc flash labeling requirements. Employers, not manufacturers or installers, are responsible for complying with the National Electric Code labeling requirements. Switchboards, panel boards, industrial control panels, and motor control centers must be field marked. Many companies are also marking conduits, disconnect switches, and any other equipment where the risk of arc flash exists. Any equipment installed after 2002 needs to be labeled. For equipment installed before 2002, labeling must be applied if any modifications or upgrades take place. Smart employers are taking the safe, efficient approach of labeling all their electrical equipment regardless of when it was installed. The marking must be clearly visible to qualified persons before they examine, adjust, service, or perform maintenance on the equipment. The NFPA 70E requirements also ensure a qualified employee is present wherever there is a potential for arc flash. Overall, these requirements are intended to reduce the instances of serious injury or death resulting from arc flash. The information on the field label should warn employees and other workers that a serious hazard exists and appropriate work practices and PPE should be used. Work permits are basically the same as hot work permits we have used for many years. It provides the requirement that a competent person or supervisor has reviewed the electrical work plan and has given approval for such work. The purpose of the work permit is to provide an additional layer of supervision and approval before the work can begin. You've heard so much about lockout and tagout for hazardous energy sources, including electrical lock and tagout, you're probably tired of hearing about it. Well, it's a sad thing when everyone has been trained and reminded of lockout and tagout, but we still keep experiencing these accidents, injuries, and deaths because of poor or non-existent lockout and tagout procedures. We just want to make the point that if you work around or near machines, you need lockout-tagout training. You need to know not to remove tags or locks unless you are the person placing the tag or lock on the equipment. If you work on machinery or electrical equipment, you need to follow company policies and procedures. Lockout and tagout is an excellent method of preventing accidents, injuries, and deaths. Do your part. Follow the rules. Where and when to perform arc flash hazards. Hazardous arc flash can occur in any electrical device regardless of voltage in which energy is high enough to sustain an arc. In industrial settings, common places for a fault include panel boards and switchboards, motor control centers, metal-clad switchgear, transformers, motor starters, high voltage switching and grounding, pad mount switching, meter bases and meter banks. Any place that can have equipment failure. Some of the employees that are affected by arc flash hazards are maintenance workers, electricians, operators, and HVAC personnel. Examples of tasks that require file-rated clothing under NFPA 70E are removing or installing circuit breakers or fuses, low voltage testing, working on control circuits when energized parts exposed, applying safety grounds, racking circuit breakers, racking starters, removing bolted covers. The 2000 NFPA 70E and the 2002 NEC state that facilities must provide a safety program with well-defined responsibilities, calculations for the degree of arc flash hazard, personal protective equipment for workers, training for workers, tools for safe work, warning labels on equipment, and of course, documentation for all of these items. One document that provides guidance for addressing arc flash is NFPA 70E, Standard for Electrical Safety Requirements for Employee Workplaces. In short, NFPA 70E requires that limited approach, restricted approach, and prohibited approach boundaries need to be established in order to assure that personnel do not accidentally contact exposed, energized electrical equipment. Employees are aware of potential hazards when operating, changing the position of, or working in the proximity of energized electrical equipment. If an employee needs to enter a flash boundary to perform work that could possibly cause an arc flash, then special personal protective equipment must be worn. The type of PPE depends on the amount of energy to which an employee could be exposed. An arc flash analysis needs to be developed in order to determine the type of PPE needed for the energy level, the duration of an arc flash, and the working distance. When arc flash incidents occur, typical injuries are burns resulting from the arc flash and ignition of flammable clothing. Some incidents are so severe that treatment at a burn center is required. Arc blasts also create extreme pressure bursts and high temperatures that cause rapid heating of surrounding air. Typical arc flash incident injuries include burns, loss of hearing, concussions, loss of sight, collapsed lungs, broken bones, loss of limb, loss of life. The best way to prevent an arc flash is to de-energize electrical circuits when equipment is being prepared for maintenance or inspection, as well as when equipment is being returned to service after maintenance has been completed. New equipment can provide for faster clearing times, alternative short-circuit detection, improved work methods, etc. that minimize arc flash hazards. Whether working with new equipment or older equipment, requirements of NFPA 70E and OSHA must be included, and coordination studies, short-circuit studies, and arc flash analysis must be developed. The more serious problem lies with older facilities which have not been upgraded and are still using older technology. Older design philosophies may result in longer short-circuit clearing times that can result in more serious injuries should an arc flash incident occur. Electrical safety is nothing new, nor is hazard assessment. It's just something that is required and must be done for safety. Take a long look at your facility and operations. Make sure you're meeting NFPA 70E and OSHA requirements. Take the time to do the hazard analysis and evaluations. Find out what type of PPE is required and when to use it. And above all, implement your training program so everyone will have the proper information to protect themselves.